it is based on saliva. Later we're going to have a breathable test, but mainly it's a PCR test, the one we take for COVID. Yes, that one is not an antigen test. No? It's not something that just takes just traces of antigens. No, it's a complete PCR test that is done in 20 minutes, portable, disposable. It can detect cancer and detect viruses, and detect even simultaneous kinds of viruses. So with a single sample, we can test COVID, and we can test just common flu. We can test different kinds of viruses. So I leave you with Gusto, who's going to tell us about that.
Thank you, Dr. Rogers. Well, thank you everybody for this time. I don't want to come here to talk about diseases, so this is not a story about diseases, it's more like a story about hope. And this is a story about hope, mostly because when talking about cancer, the cancer rates every year, and as well as other infectious diseases, are kind of complicated. We suffer right now in COVID like a mass casualty event. And right now we're talking about that almost 33 million people are suffering from cancer right now. And it's expected that by 2030, we are talking about 70% of the people maybe is having some kind of cancer. It means that thousands of people, brothers, fathers, doctors, athletes, can be suffering some kind of cancer, some kind of silent disease at a time. Most of these diseases are really preventable with early molecular diagnostics. The big problem is, and putting as an example the lung cancer, is when the cancer is exactly in the phase of detection, it's also in the invasive part of the cancer. This is extracted directly from the archives of the WHO, head and neck cancer, lung cancer, and unfortunately, when the early diagnosis is done, we are also in the phase of invasive cancer. So what if I could tell you a story about using liquid biopsy? A liquid biopsy being blood or saliva? Because as you may know, the most tumoral or the disease tissue of the host is releasing all this genetic information, has been fingerprints into the circulatory system. So most of the polymorphism, mutations, methylations, which can be really predictable tools for detection of the cancer. So what if we can make a mix and get a technology to analyze the data, to analyze these fingerprints using ancestry genes, methylated genes, oncogenic genes, changes in the different transformations that the cells are suffering right now. What if we can get all these molecular profile and use it for prognosis and the prevention to take the better or the best therapeutic medical decisions using just a simple sample of blood or saliva? Well, saliva is the future, because I guess even when saliva is having just 1,000 to 10,000 times less genetic compounds than the blood, is the best and friendly option for the patient. So what if we can present to you a future? This is a prototype. We already have it in the technology readiness level in 5, which means that we have fully tested this device in laboratory conditions, in real samples from patients, taken from COVID samples from patients, for infectious diseases, and also for chronic non-transmissible diseases, cancer, especially lung cancer. Before this starts, I want to show you technology, the versatile technology that can be adapted for early molecular diagnosis.
Take a look at the
The device is named Signal 1. And device is named Signal 1. It's a portable device which has a pressurized division to maintain the heat, exactly the heat is needed to separate the sample, amplify the sample, and give you a molecular diagnostics, making a PCR on place. It has a pocket basically to receive the sample, being blood or saliva. The sample will be grazed through in a specific panel. In the same panel, the sample will be purified. Basically, it will be in touch with specific molecular sequences we will have into the panel. And after that, in the same panel, we will have right now, a qualitative data, but we are working on specific quantitative data for it. It is already having the protection, the IP protection. We have been working hard on the IP protection, on the different characteristics from the scientific standpoint, in order to have a versatile technology, to have the possibility to change the diagnostic tools in the world, recognizing DNA and different metabolites, biomarkers specific for specific disease. This is not a device that will do differentiations, not for one side infectious disease and at the same time chronic non-infectious disease. No, this is a device that will be or is created exactly at this point for a specific biomarkers for a specific disease. So we have a device named Signal 1 for lung cancer, and we have another device named RPP, the respiratory virus panel, pathogens panel, that will be mostly for the differentiation between SARS-CoV-2, influenza A and B, adenovirus, and other respiratory viruses. All in order to help and make easy the possibility of the diagnostics. I don't know if this is a question maybe you're having right now. We are giving the results in less than 30 minutes with just a simple sample or just a simple drop of blood or saliva right now. So at this point, thank you very much. This is what we want to present. I don't want to boring these people right now with this, but I hope we can change the future of the diagnostic pretty soon. Thank you very much.